This is a demo of ModSquad, the TA3 from Purdue on the Data Discovery Models program. And this is a short walkthrough video to familiarize you with the interface. It's pretty simple, so it shouldn't be too difficult. This isn't a final form interface. There's going to be some changes before we do the final training and you get a chance to use it, but this will give you the flavor. It's going to be initialized with a pre-selected problem. And so you have a little welcome screen here. When you get ready to go, you can go to the problem, and the problem itself will be described here. Some of the problems have little descriptions, and they can tell you a little bit about the problem, but also the team staff themselves will explain to you about the problem and what the goal is in terms of exploring some data. Most of these problems you can think of conceptually as a data table with a number of columns that are features and a number of rows that are kind of the individual measurements. And we have a chance to, we're working our way from the left tab to the right tab as we do an exploration of this data set. First, we can just look at which features are there. And this data set we're using for a sample is a baseball data set. So you can see the columns that are in the data set are like hits and batting average and the slugging percentage and those kind of things. And you get a chance to explore, this is described in this text up here, but you can take a look at any of the particular features by clicking right on the word. And it expands this little tab and it shows you of all the rows in this database, here's sort of a sizing. You know, you can take a look at the number of records that had values between 1 and 200, number of records that had values between 2 and 300. This is the doubles. So this many players, 400 players had a number of doubles between 100 and 200. And so this is a way to explore it. You can move your mouse and do a little bit of resizing and rescoping of these interfaces. The top one is what is generally called a histogram. It gives you an overall distribution of the data set. And this bottom one is called a QQ plot or a normal plot. And if this line is pretty much diagonal and straight, then this variable, the doubles here, has sort of what's called a Gaussian distribution. It has a lot of center points, and then it has a couple small points and a couple big points. You can think of it as like also called a bell curve. Most of its values are around a certain center point with a spread of bigger and lower values. The closer to that perfect bell curve that this value is, the more straight and like 45-degree angle this will be. So this particular interface, you can look at individual data points in the data set and just get a familiarizing yourself with it. Like, okay, well, how many triples were done? Is there, okay, you can see triples are there's more people that have fewer triples. There's 600 players that have between 0 and 50 triples. And that makes sense. So as you go up, there's fewer players that have a lot of triples because of how difficult that is to hit. So this is a way, this panel can let you explore variables one at a time in your data set. We also sometimes will use the word variable and feature interchangeably. So I apologize if that's confusing. Now let's dig a little bit deeper and try to see relationships between them. Generally, when you have a problem that's assigned, there's a certain thing we're trying to estimate. We're trying to decide which of these players gets into the Hall of Fame, for example, or we're trying to decide how their batting average affects the other variables that they do. And so we can, if we're trying to understand a particular variable and how it's related, we pick that variable. It's called our target. We're going to study this one and see how it's related to others. Let's do doubles again. So we're going to generate a number of plots, and these plots show us our target variable, which over here is the y doubles, and how their value relates to each of the other features that are in the data set. And so what you're looking for here in a pairwise set is, are these points kind of linear and angled? These are correlated, so people who have more hits tend to have more doubles. That makes some sense. Is there a correlation between batting average? Not as much as there is directly from number of hits, number of doubles. So here we're looking at we're looking at variables 2 at a time, and you can decide, is your slugging percentage, do you get a hit when there's people on base? Is that related to your doubles? Well, kind of, but not as directly as your original performance. So this is the same section here that that we get to take a look at. And anyway, so here is 2 variables at a time, and this is to give you just an idea of how these interactions are occurring, because the automatic methods that this program is developing can do very interesting exploration things, but they can't replace the subject matter expertise. So we want the subject matter expert and user to have some time exploring their variables. Okay, now the next place we come over here is being able to run a model on that data set and take a look at the predictions. And so how we do that is by selecting one, and then just connecting to that model. So we're reaching out to go get to that model, and then we're going to say, I want to train this model to try to make it fit, make it study that variable that we were exploring, and then when it gets done, it's going to bring back results here. This is the part in our video where these results don't show at this point yet, but I wanted you. This is the process where you connect to your model and then actually run that model, and it's going to give you a couple predicted results here, and then we can explore those predicted results one at a time. I'm going to show you ones that as if we got them back here, and so this panel is going to have specific guesses from the automatic system that you'll look at one at a time and decide which one you like the best. And we can tell that by going to this model output and viewing the results of one of those models. Here is the idea of how we're asking it to predict all these variables, like the batting average based on the number of hits. And we're seeing on the left side of this plot is the actual data points in blue and the guess from the computer model in black. And you can just look at that and decide, does it seem to cover, does it fit most of those things? And the plots on the right are called residual plots. And this is if you subtract what would the actual data and the computer model's guess, what value do you get differently, and you plot that. So this is like an error plot here. It's called the residuals. It's just how much error was in the result of the model that was tried to predict this data. So here's an opportunity to look at each of these variables and how the prediction fits and what error is left over. So the process that we want you to do is to go back and forth here. Once we've trained this model, take a look at the different predictions that it makes, go and look at these output visualizations for each of those predictions, and decide which one looks like it fits the data best and answers the question you're trying to pose the best. And then we go back into this panel, and there'll be an opportunity to say, select this one. So you can pick the best one here. And when you're all finished, we come here and just go ahead and stop the demonstration, and we stop the tape. Thank you so much for your time.